Hi guys, this is Saurav and welcome to Online Pathshala, Vedantu's initiative to make education accessible to everybody across the country. This session is done on the topic liquid solutions and आज का जो session है that will be done on non-ideal solutions. So before we start with this session, a warm welcome to everybody who is joining us. Hello everyone, कैसे हो सब लोग? क्या हाल चाल? I hope everybody among you is doing as good as possible और पढ़ाई वढ़ाई कर रहे हो, सब कुछ ठीक ठाक है. Okay? So हमारा टॉपिक आज का है liquid solutions में non-ideal solutions and non-ideal solutions में we will be discussing a few important concepts. बट मैं आपको पहले बता देना चाह रहा हूं कि नॉन आइडियल सॉल्यूशंस हम लोग दो पार्ट्स में करेंगे. विल बी डिस्कसिंग नॉन आइडियल सॉल्यूशंस इन टू पार्ट्स. This lecture is non-ideal solution part 1, and in the next class we will be talking about non-ideal solutions part 2, in which we would be taking up the more critical thermodynamic considerations and azeotropic mixture. So आज के क्लास में हम समझेंगे कि what are non-ideal solutions, and we'll take some questions on what non-ideal solutions are and how different are they from ideal solutions. But before we start, I would like to tell you that आज की क्लास 4 बजे विकास सर की थी, but -5 o'clock class is non-ideal solutions. Then Pulkit sir will be taking session on inverse trigonometric functions at 6 o'clock. Please do join the 6 o'clock session for Pulkit sir. Okay? Download the Vedantu learning app because amazing content at one place, and you can get all our session PDFs, all the video lectures, all the online tests, and जो भी आपके doubts हैं वो आपके clarify होते रहते हैं. Okay? It is also important to know that हम लोग ने Telegram group start किया है, and Telegram group is where you can interact with us, you can interact with our academic mentors, you can post your doubts, you can interact with the teachers on a regular basis, you can interact so as to resolve your doubts. बहुत आराम से आप रिजॉल्व कर सकते हैं. असाइनमेंट्स होते हैं, पोल्स होते हैं. यू कैन बी अपडेटेड विद लॉट ऑफ कंटेंट विच इज गोइंग टू गो ऑन वेदांतु लर्निंग ऐप. ओके, वेदांतु इज द ओनली ऑनलाइन प्लेटफॉर्म. भाई जितने यूट्यूब पे ऑनलाइन प्लेटफॉर्म्स हैं, जिसको भी आप ले लो, कोई भी आप उठा लो, किसी के पास रिजल्ट्स नहीं है, बट वेदांतु इज द वन हु हैज गॉट 3 रैंक्स अंडर टॉप 50. ओके, वी हैव सुमित who has got the first rank in the physically disabled category, Chirag and Rajdeep, Prakhar, Nivedya, Sanket. These guys are the ones who are stars, जिन्होंने online class को use करके they have done marvelous. Okay, you should watch the success stories on our Vedantu JEE channel and the Vedantu NEET channel. Success stories, mark it a point to watch these success stories because they will motivate you like anything. Okay, and please do like, share and subscribe to our channel because अगर आप like करते हैं, subscribe करते हैं, you are doing a nice thing. You are updated with all the nice content, you are updated with all the brilliant aspects that the channel has to offer. Please do that. Okay, this is my request to you guys, that whosoever you are, please do subscribe to our channel so as to be updated with all the awesome content that comes on our channel. Okay, with this in mind, let's start today's session. What is a ideal solution and how is a non-ideal solution different from it? देखते हैं क्या होता है. What is meant by an ideal solution? Ideal solution क्या होता है? Ideal solution वो होता है which is very very similar to a ideal gas in all properties. देखो, ideal gas जो हम लेते हैं उसमें हम क्या assume करते हैं कि all particles behave alike. If I take an ideal gas of hydrogen and if I take ideal gas as nitrogen, nitrogen और hydrogen के molecules के बीच में कोई difference नहीं है. Similarly, ideal solution whosoever is making, there is absolutely no difference in the nature of interactions of these two particles. For example, I'll get to that. Okay, इसमें एक और consideration आता है. We'll get to that little later. So, if I take two substances A and B, let's say I have taken benzene and toluene. I mix benzene and toluene. Benzene molecule के around एक benzene molecule है, toluene molecule के around एक toluene molecule है, so they experience a certain kind of force. Now when benzene is around a toluene molecule and toluene is around benzene molecules, उसमें भी कोई भी force का या फिर force of interaction का कोई difference नहीं होता है. Okay, at every range of concentration, at every point, there is absolutely no difference in the nature of interaction of the two entities which are present simultaneously in the solution. Okay, so AB interaction is nearly equal to AA interaction and BB interaction. So we'll identify later on key what example should we take for ideal solution, how to like be proficient to identify. याद करने की जरूरत है या फिर नहीं याद करके एक कंसेप्ट से वर्क करता है. There is one another consideration that the ideal solutions obey Raoult's law. Now Raoult's law थी क्या? If you remember, Raoult's law was talking about the force of attraction. The Raoult's law was talking about the force of the vapor pressure. Raoult's law was talking about the vapor pressure of solution. Let's say there are two components. Component A's vapor pressure is P naught A and its mole fraction is A, and component B vapor pressure is P naught B and its mole fraction is B. So vapor pressure of solution will be equal to the partial pressure of both the solvents vapors. Okay, both the solvents vapor which you have mixed together. ये हमने पहले cover कर लिया है. If anybody has a query, please do watch our session which we have done on Raoult's law. इसको बहुत detail में हमने किया है. So vapor pressure of solution is equal to the sum of partial pressures. Now अगर हम ये consideration use करते हैं, that makes it a ideal solution. That makes it a ideal solution. There is one another feature as well. देखो, जब हम दो liquids को mix करते हैं and if the nature of forces are not changing, तो कोई heat expansion के लिए use नहीं होती है, कोई heat is not given out when molecules come to closer. Okay, so if the nature of forces remain the same, the delta H for mixing and the delta V for mixing remain the same. That means if you have taken 50 ml of one liquid and 50 ml of another liquid which both are forming ideal solution and mix them together, total volume 100 ml क्या theoretically भी रहेगा, experimentally भी रहेगा. Okay, theoretically भी रहेगा, experimentally भी रहेगा. So delta V mixing is 0 and delta H mixing is also 0. Delta H mixing 0 इसलिए होता है क्योंकि delta H जो होता है that comes out as heat. Delta H को क्या बोलते हैं? Enthalpy. मतलब heat बाहर release हो सकती है और heat can be taken in. Heat will be released outside if more attraction takes place. Heat will be taken in if repulsion takes place. Okay, so enthalpy change will be positive or negative depending on whether there is attraction or whether there is repulsion. Okay, so enthalpy change जीरो हो सकता है, नेगेटिव हो सकता है, पॉजिटिव भी हो सकता है, बट ये आपको याद रखना होगा, अगर अट्रैक्टिव फोर्सेस डोमिनेंट रहें देन हीट विल बी रिलीज्ड. इफ रिपल्सिव फोर्सेस डोमिनेंट और अट्रैक्टिव फोर्सेस कम हो जा रहे हैं देन हीट विल बी एब्जॉर्ब्ड. So delta H of mixing is 0 because no heat is evolved, no heat is absorbed, forces of attraction remain the same. So because interactions are same before and after mixing of the solution. Okay, so that is the reason delta H of mixing delta. So this is a very important condition for a solution to be called a ideal solution. एक और चीज आप जान सकते हो, there is something known as delta S for mixing. The entropy change for mixing. Entropy change of mixing will always be positive. बिकॉज नंबर ऑफ पार्टिकल्स इंक्रीज कर रहे हैं. फॉर एग्जाम्पल, आप समझ लीजिए कि आई टेक अ सॉल्वेंट विच कंटेन्स अ सर्टेन नंबर ऑफ मॉलिक्यूल्स, उसमें मैंने कोई और सॉल्वेंट डाल दिया विच कंटेन्स सम एक्स नंबर ऑफ मॉलिक्यूल्स, बोथ come together, number of molecules increase, randomness increases, so delta S for mixing will always be positive and delta G for mixing will always be negative. The reason is delta G is equal to delta H minus T delta S. Delta H तो 0 हो गया and this is positive, so delta G will be negative. Okay. Delta G will be negative. Now let's understand it using this video, that what is meant by delta V to be equal, or delta V to be equal to 0. So what we have done is we have taken two liquids and उसके इक्वल वॉल्यूम्स हमने मिक्स कर दिए हैं. सो व्हाट यू कैन सी ओवर हियर इज द डेल्टा टोटल वॉल्यूम जो आपने कैलकुलेट किया एंड टोटल वॉल्यूम जो आपने ऑब्जर्व किया, वो दोनों इक्वल आ जाएंगे. सो व्हाट यू आर सीइंग ओवर हियर इज मिथानॉल मैंने 50 ml लिया है एंड आई हैव टेकन इथेनॉल 50 ml. तो दोनों की प्रॉपर्टी एक ऑलमोस्ट सिमिलर है. बोथ ऑफ देम आर अल्कोहल्स. Both of them, when they are mixed, the total volume will become equal to 100. If it is ideal, it will become 100. But if it is non-ideal, it may be less than 100, it may be more than 100. Okay? It may be less than 100 or it may be more than 100. Now somebody is asking that, sir, why the force of attraction remains the same? The answer to that question is because the nature of molecules remains the same. Let's look at the few examples of ideal solution. The few examples of ideal solution are N-hexane and N-heptane. One of the examples is N-hexane and N-heptane. Hexane molecule इस तरह का रहेगा 1 2 3 4 5 6. Both of them are hydrocarbons, similar properties. So nature of interaction will also be the same. Chlorobenzene, bromobenzene, similar molecules, haloarenes. Okay. Ethyl bromide, ethyl chloride. Nature of molecule is not changing by a lot extent. आप क्या कर रहे हैं कि कुछ ग्रुप्स को ऐड कर दे रहे हैं and you're increasing the molecular weight, but that does not change the nature of the molecule to a very large extent. Okay. Azeotrophs do not obey Raoult's law. No, they do not obey Raoult's law. That is the reason they are known as non-ideal solutions. We'll discuss this later in the next session, that why or what solutions will form azeotrophs. CCl4 and SiCl4, similar property. Ethyl bromide, ethyl iodide, similar property. Benzene and toluene, similar property. So आप देख लो, हमेशा याद रखो, in a hydrocarbon series, homologous आप जानते हैं, homologous series आप जानते हैं what they are. They differ by hexane. The formula is written as C6H14 and heptane will be written as C7H16. So what is the difference of a CH2 unit? The difference is of a CH2 unit. So remember that whenever there is a homologous series के कोई दो adjacent molecules ले लिया हमने, I have taken hexane and heptane, I will obtain an ideal solution. Similarly, if you compare benzene and toluene, कितने का difference आ रहा है? I am getting a difference of a CH2 unit. So whenever we have an example where there are members of the same homologous series, I will get an ideal solution. For example, another example that I can take is methanol and ethanol. Similar molecules, difference, alcohols, homologous series because they differ by CH2 unit. Okay. So this is very, very important. If I look at a ideal solution graphically, then graphically हम उसको इस तरह से assume कर सकते हैं कि we have discussed this earlier as well. If we are plotting vapor pressure versus composition, what we obtain is, if there are two liquids A and B, if there are two liquids A and B, so what you are seeing over here is P naught A is less than P naught B. P naught A is less than P naught B. It means which is more volatile? Okay, which is more volatile? The Deviation ideal gas law is something which you read in 11th standard, so I'm not going to discuss that. This is a 12th standard topic. Okay, so P naught B, which is more volatile? If I am getting more vapor pressure, that means B is more volatile, and this is less volatile. Okay, B is more volatile, A is less volatile. Because of that, I look at the ideal vapor pressure of B is more than the ideal vapor pressure of A. Now we know that the vapor pressure due to any substance is equal to the mole fraction of that substance times the ideal vapor pressure. So the vapor pressure of that substance is equal to the mole fraction times the ideal vapor pressure. So it will follow a straight line path, like a y equals to mx wala path plot follow karega. So this is vapor pressure of A across different compositions. This is vapor pressure of B across different composition. The total pressure, this line shows the total pressure, which is PA plus PB. ये हमने पहले cover कर लिया है. This we have already covered earlier. Okay, I hope there is no confusion this one. This we have already covered earlier. So this is the plot that would be followed for any ideal solution. This will be followed for any ideal solution. Okay, किसी भी ideal solution के लिए ये follow होगा. Okay. Now, अगर boiling point versus composition plot आप लेते हैं, तो boiling point versus composition plot will be like this for any ideal solution. You can see that what I had taken earlier is that vapor pressure of A is less than vapor pressure of B, so boiling point of A will be more than boiling point of B. Okay, this is what we are observing. Boiling point of A is more than boiling point of B, so we will be observing a boiling point versus composition plot will be like this. Boiling point versus composition plot will be like this. So remember, for an ideal solution, वेपर प्रेशर वर्सेस कंपोजिशन, बॉइलिंग पॉइंट वर्सेस कंपोजिशन प्लॉट आपको याद होना चाहिए किस तरह का दिखता है. व्हाट इज द असेसमेंट, ये हमने पहले के वीडियोस में कवर कर लिया है. हाउ टू आइडेंटिफाई व्हाट विल बी ऑब्टेन्ड ड्यूरिंग डिस्टिलेशन. ओके, सो प्लीज टेल मी इफ यू रिमेंबर दैट बॉइलिंग पॉइंट, हाउ टू आइडेंटिफाई what will be obtained after distillation. आपको याद है लीवर रूल हमने बताया था in the previous videos. Have you watched that? Okay, so with that idea in mind, let's take a question. एक क्वेश्चन लेते हैं. क्वेश्चन अच्छे से पढ़ के समझने की कोशिश कीजिए. क्या लिखा है? The following graph is plotted at constant pressure. Okay, the following graph is plotted at constant pressure. If x and y represent the mole fraction in the liquid and vapor phase respectively, x and y represent vapor pressure in liquid and vapor phase respectively, which of the following statements is or are correct? It could be a multi-option correct question, but using whatever we have learnt earlier, we will try to solve this question. Okay, so you can see this plot. लेट्स अटेम्प्ट टू सॉल्व दिस क्वेश्चन. क्वेश्चन को सॉल्व कैसे करना है? ओके, पहले देखते हैं इस क्वेश्चन को सॉल्व कैसे करना है. बहुत इजी सा सवाल है. इसको you do not have to work really hard on it, but you have to be little careful. Let's look at what the plot is about. The plot is of boiling point versus mole fraction. Okay, boiling point versus mole fraction. Can you see that at this end, mole fraction of benzene is 1. That means यहाँ पे हमने pure benzene लिया है. This is boiling point of benzene. Okay, this is boiling point of benzene, and this is boiling point of toluene. Okay, Beer-Lambert's law is not there. हमें Beer-Lambert's law यूज ही नहीं करना है यहाँ पे. Okay, so this is boiling point of toluene. Now this plot that you are seeing, composition, ये composition किसके लिए increase कर रही है? आप देख रहे हैं, this is 0, 1, 2, 3. So at this point, if mole fraction of benzene is 1, what will be the mole fraction of toluene at this point? Can you tell me what will be the mole fraction of toluene at this point at the extreme left hand side? कितना mole fraction होगा? The mole fraction of toluene is 0. Okay, toluene का यहाँ पे 0 है, and यहाँ पे toluene is becoming 1. So over here mole fraction of benzene is equal to 0. Okay, over here mole fraction of benzene is equal to 0. I hope this is understood. Now आप देख रहे हैं ये values 0, 1, 2, 0.1, 0.2, 0.3, 0.4 ऐसे increase करते हुए this value is going all the way to 1. Okay, this value is going all the way to 1. So can you tell me something? ये जो increase होते हुए mole fraction आपको दिख रहे हैं, ये increase होता हुआ mole fraction क्या toluene के लिए है और it is for benzene? You are seeing an increase in mole fractions. Is this written for toluene or is it written for benzene? Please tell me in the comment section that if this is written for toluene or it is written for benzene. It's written for toluene. Very good, Munari. It's written for toluene. ठीक है? अब first question ये है कि when mole fraction of benzene is 0.5, then Y for toluene, that means mole fraction in vapor state. How do we identify that? Okay, how do we identify that? तो हम 0.5 पे लेते हैं बेंजीन को. If 0.5 of benzene will be exactly over here, मोल फ्रैक्शन ऑफ बेंजीन 0.5 एग्जैक्टली यहां पे ही रहेगा जहां पे टोलुइन का मोल फ्रैक्शन 0.5 है. नाउ इफ आई बॉयल दिस लिक्विड, it will boil at this temperature and it will create vapors according to लीवर रूल. यहां पे वेपर्स बनेंगे and then I will condense the vapors. याद है, we had discussed this. Okay, we had discussed this. I am taking this liquid, boiling it. It will boil at this temperature. लीवर रूल के हिसाब से इसके स्ट्रेट जहां पे ये पॉइंट को बाइसेक्ट कर रहा है, that will be the vapor which will be created. I condense it, I will get these vapors. Okay, I will condense, I will get the vapors at this point. ये हमारे vapors हो गए. Is that understood? काजल गुप्ता, हेनरीज लॉ पे बाद में आते हैं ना, दिस इज नॉट हेनरीज लॉ, वी आर डिस्कसिंग समथिंग एल्स, वी आर डिस्कसिंग ideal solution and non-ideal solutions. We'll get to Henry's law later on. Okay, so boiling, condensation. When condensation takes place, can you tell me what is the composition? ये composition क्या है? Can you tell me what is the composition? The composition over here is 0.2 for mole fraction of toluene and 0.8 which is mole fraction of benzene. Can I say this? 0.2 mole fraction of toluene and 0.8 mole fraction of benzene. तो ये जो कंपोजिशन आपको मिल रहा है एग्जैक्टली यही कंपोजिशन वेपर फेज में भी रहा होगा. ट्राई एंड अंडरस्टैंड. जो हमें कंडेंसेशन के बाद मिलता है दैट इज ऑब्टेन्ड आफ्टर कंडेंसिंग द वेपर. सो यही कंपोजिशन वेपर फेज में भी रहा होगा. This is our vapor phase composition. Okay, this is our vapor phase composition. So if this is our vapor phase composition, what is the vapor phase composition of toluene? 0.2. So the first statement becomes correct. Aditya Roy, azeotropic mixture is an example of non-ideal solution. Yes. Is this understood? That जब हम इसको condense कर रहे हैं देन जो लिक्विड हमें मिलता है वो इस वेपर को कंडेंस करने के कारण मिल रहा है. सो वट एवर इज द लिक्विड कंपोजिशन इज एग्जैक्टली द वेपर कंपोजिशन. सो दिस कंपोजिशन इज फॉर द वेपर एज वेल. एंड वेपर में कितना टॉलुइन प्रेजेंट था? 0.2, बिकॉज लिक्विड जो कंडेंस होके आया वहां पे 0.2 प्रेजेंट है. इज दिस अंडरस्टूड? प्लीज टेल मी इन द चैट बॉक्स इफ दिस इज अंडरस्टूड. देन वी कैन प्रोसीड ऑन टू द अदर ऑप्शंस. Now, if I take the B option, mole fraction of toluene is 0.3. So let's take if I take mole fraction of toluene as 0.3, so toluene का mole fraction हम ले लेते हैं 0.3. Okay, now when I condense this, I will obtain something over here, boiling. So this is boiling and this is condensation. When I perform this condensation, I will get this liquid whose composition is mole fraction of toluene कितना है? 0.1 and mole fraction of benzene इस पॉइंट पे कितना रहेगा? 0.9. ओके, यार ग्राफ नहीं दिया रहेगा तो आप फाइंड नहीं कर सकते हो. ओके, इफ ग्राफ इज नॉट गिवन यू विल नॉट बी एबल टू फाइंड. ग्राफ इज गिवन सो वी नीड टू यूज द ग्राफ. ओके, सो what does this represent? This represents composition in vapor phase. This represents composition in vapor phase. So what is the composition of benzene that we are obtaining in vapor phase? Y represents in composition in vapor phase. It is written as 0.6, but it is coming as 0.9. So B is incorrect. Okay, it is incorrect. ठीक है. What about the C option? When mole fraction of benzene is 0.3, then mole fraction of toluene is 0.4. So benzene is 0.3. Okay, benzene is 0.3. benzene 0.3 कब रहेगा? इस पॉइंट पे. When toluene is 0.7, benzene will be 0.3. When toluene is 0.7, benzene will be 0.3. Boil किया, condense किया. Okay, when I boil this, I condense this. So when I condense this, what is the composition that I obtain? Mole fraction of toluene is 0.4 and mole fraction of benzene will turn out to be 0.6. Okay, I boil this, I obtain this as the condensate, and mole fraction of toluene at this point is 0.4 and benzene is 0.6. अगर ये दोनों मिल गए हमें, so that means this is again the composition in vapor phase. देखिए क्या स्टेटमेंट दिया गया है. Mole fraction of benzene is 0.3 and mole fraction of toluene in vapor phase is 0.4. Are we getting it as 0.4? Yes. C is also correct. C is also correct. So the question is थोड़ा एडवांस लेवल का क्वेश्चन है, बट मैंने इसलिए लिया ताकि आप लोगों को ये प्लॉट समझ में आ जाए. ओके, दिस क्वेश्चन इज नॉट वेरी स्ट्रेट फॉरवर्ड बट इज इंटरेस्टिंग टू सॉल्व. ओके, इसमें बहुत ज़्यादा कोई मेहनत नहीं करनी है, आपको बस लीवर रूल याद रखना है. लास्ट वाला ऑप्शन देखते हैं. व्हाट इज द लास्ट ऑप्शन? ओके, लेट्स टेक द लास्ट ऑप्शन. लास्ट ऑप्शन इज व्हेन मोल फ्रैक्शन ऑफ बेंजीन इज 0.7. तो यहां पे मोल फ्रैक्शन बेंजीन 0.7 रहेगा. व्हेन मोल फ्रैक्शन ऑफ टॉलुइन इज 0.3, मोल फ्रैक्शन ऑफ बेंजीन इज 0.7. आई बॉयल दिस, I'll obtain this. Okay, I boil this, I obtain this. What is the composition? Mole fraction of toluene is 0.1, mole fraction of benzene is 0.9. This is again the composition in vapor phase. इसके vapor phase का composition है. What is given as the option? Mole fraction of benzene is 0.7. Then vapor phase composition of toluene is less than 0.3. Is this statement correct or incorrect? Correct. So हमारे correct statements क्या क्या आ गए? A is correct, C is correct, D is correct, D is incorrect. Okay, A is correct, C is correct, and D is incorrect. Please do re-watch the video so as to understand this question in a greater detail, क्योंकि ये question बहुत simple but थोड़ा सा टेक्निकली डिफिकल्ट हो जाता है. ठीक है, लेट्स टॉक अबाउट व्हाट इज अ नॉन आइडियल सॉल्यूशन. ओके, लेंदी तो रहेगा, लेंदी हो ही सकता है. अब क्वेश्चन आपके हिसाब से तो नहीं आएंगे. ठीक है, क्वेश्चन भी इजी आए और लेंदी भी ना रहे, ऐसा हो नहीं सकता है. सो दिस इज इजी क्वेश्चन दो अ लिटिल लेंदी वन. एक बार आप थोड़ा सा सॉल्व कर लोगे, it will become easier for you to solve. What is meant by non-ideal solution? तो non-ideal solution होता क्या है? Non-ideal solutions are the ones which do not obey Raoult's law. Raoult's law ये कहता है कि the sum of vapor pressure of two solvents can be given by a equation. Okay, so let me explain this in very simple manner. Raoult's law ये कहता है कि total pressure is equal to mole fraction of solvent 1 times P naught A plus mole fraction of solvent B is P naught B. This is what Raoult's law says. Okay, this is what. Okay, so somebody is asking, sir, this is very time consuming, should we attempt this in the examination? If you want to get into a college, आपको सॉल्व करना पड़ेगा यार. ठीक है, आपके पास दो ऑप्शन है, या तो आप कम मार्क्स लाइए एंड चैन की ज़िंदगी लीड कीजिए, या फिर थोड़ा मेहनत करके अच्छे कॉलेज में चले जाइए. तो अच्छे कॉलेज में जाने के लिए यू नीड टू सॉल्व एडवांस लेवल क्वेश्चंस, और एडवांस लेवल क्वेश्चंस तो थोड़ा टाइम कंज्यूमिंग होंगे ही, सो यू हैव टू सॉल्व इट. सो दिस इज व्हाट Raoult's law suggests, and this is what is, let's say, calculated. This is what we calculate. Okay, but let's say PT observed is not equal to P calculated. Let's say it is not equal to P calculated. It is, if it is not equal, it can be either greater or lesser, and in such a scenario we call the solution a non-ideal solution. So when the vapor pressure of the total solution experimentally is not the same as that we expect from Raoult's law, then we call it a non-ideal solution. ओके, नॉन आइडियल सॉल्यूशन के केस में दो केसेस आते हैं. एक केस होता है जहां पर कि अट्रैक्शन होता है एंड वन वेयर रिपल्शन टेक्स प्लेस. तो दो केस आते हैं. वन केस इज नोन एज पॉजिटिव डेविएशन फ्रॉम राउल्ट्स लॉ एंड वन इज नोन एज नेगेटिव डेविएशन फ्रॉम राउल्ट्स लॉ. पॉजिटिव डेविएशन क्या होता है? इन पॉजिटिव डेविएशन द टोटल प्रेशर ऑब्जर्व्ड विल बी मोर देन द वन विच इज कैलकुलेटेड. ओके, okay, so total pressure observed will be more than total pressure calculated. For example, suppose आपने two liquids लिया A and B and you mix them together and you know their mole fraction. उसका Raoult's law लगा के आपने एक vapor pressure calculate कर लिया. आपने बोला कि mole fraction of A is 0.5, mole fraction of B is also 0.5, P naught A is 100, P naught B is 50. तो आपने P total निकाला. P total आपने कितना निकाला? 50 plus 25, 75 आपने निकाल दिया. Okay, let's say mm है. So you have calculated P total as 75. But आपने experiment जब किया and you get the P observed as more than 75, आपको P observed जो मिला है that you are getting as 80. Then you call it positive deviation. Positive deviation is not because of boiling point, not because of freezing point, not because of osmotic pressure. It's with reference to, or it is in reference to vapor pressure. Please do remember that. Please don't make this error. बहुत लोग ये मिस्टेक करते हैं क्योंकि वहां पे वो लोग डेविएशन को बॉइलिंग पॉइंट या फ्रीजिंग पॉइंट या ऑस्मोटिक प्रेशर से रिलेट कर देते हैं. डेविएशन इज रिलेटेड टू वेपर प्रेशर. ओके, सो डेविएशन इज रिलेटेड टू वेपर प्रेशर. ऑब्जर्व वेपर प्रेशर विल बी मोर देन द कैलकुलेटेड वन. ठीक है. वाई इट वेपर प्रेशर इंक्रीज कर रहे हैं? क्योंकि एस्केपिंग टेंडेंसी इंक्रीज कर रही है. Why are they escaping more quickly? Because उनके बीच में force of attraction कम हो जा रहा है. For example, दो liquid लिया हमने. Liquid के दोनों liquids के बीच में the force of attraction is decreasing as compared to the liquids individually. So the molecules will escape out and create a higher vapor pressure. Okay, so remember AB interaction is weaker than AA interaction and BB interaction. Is that clear? लेकिन अगर आपका P observed 70 mm आ जाता है, then it will be known as negative deviation. Then it will be known as negative deviation क्योंकि आपका total vapor pressure decrease कर रहा है. I hope this is understood to you guys. Please tell me if this is understood. So negative deviation कब होगा? जब मॉलिक्यूल्स जो आप ला रहे हैं, सॉल्वेंट मॉलिक्यूल्स विच आर ब्रिंगिंग क्लोज टू ईच अदर, दे अट्रैक्ट ईच अदर वेरी स्ट्रांगली. They attract each other very strongly, and so the tendency to escape decreases. Okay, tendency to escape decreases. So case 1 is positive deviation, case 2 is negative deviation. So दो तरह के deviations होते हैं. One is positive, one is negative. So AB interaction is weaker, AB interaction is stronger. Okay, AB interaction is weaker, AB interaction is stronger. Let's look at what would the plot look like. अगर हम positive deviation के लिए vapor pressure versus composition plot लेते हैं, so this is vapor pressure versus composition. Then this straight line represents P total calculated. And what is happening? The vapor pressure is increasing. So P total observed जो रहेगा, that is above this P total that you are calculating. Brownian motion means high vapor pressure? No, it doesn't mean that. Similarly, सारे molecules, you can see this is for the pure solvent, this is for the pure solvent. For them also it increases in the solution. So for everything the plot is higher because the vapor pressure increases. ऐसा नहीं होता है कि सिर्फ मिक्सचर का वेपर प्रेशर इंक्रीज कर रहा है, इंडिविजुअली इंक्रीज नहीं करता, इंडिविजुअली भी उनकी एस्केपिंग टेंडेंसी इंक्रीज कर जाती है. ओके, इंडिविजुअली भी उनकी एस्केपिंग टेंडेंसी इंक्रीज कर जाती है. सो लेट्स लुक एट सम एग्जांपल्स ऑफ पॉजिटिव डेविएशन. पॉजिटिव डेविएशन आइडेंटिफाई किस तरह से करते हैं? हाउ डू वी आइडेंटिफाई पॉजिटिव डेविएशन? Remember, the force of attraction will be decreased by some or the other molecule. For example, if I take benzene and ethyl alcohol, so ethyl alcohol has hydrogen bonding, benzene does not have hydrogen bonding or any kind of such interactions. So between two ethyl alcohol molecules, if a benzene molecule comes in, it will reduce the force of attraction and the ethyl alcohol molecules can escape quite easily. Similarly, ethyl alcohol and water. Water has a stronger hydrogen bonding, ethyl alcohol has weaker hydrogen bonding. So ethyl alcohol comes between two water molecules start escaping quite easily. So benzene and ethyl alcohol, chloroform and ethyl alcohol, benzene and acetone and two acetone molecules have dipole interaction. उनके बीच में बेंजीन आ जाएगा and it will not allow the dipole interaction to take place. That means depends on protic, aprotic solvents. Yeah, so suppose you take not aprotic, I would say polar and less polar. You can say polar and less polar. So if a more polar solvent is mixed with a less polar solvent, what happens is a polar solvent or a non-polar solvent, positive deviation will take place. So this is polar and this is non-polar, positive deviation. This is polar, this is slightly less polar, positive deviation. Polar, non-polar, positive deviation. Okay, so H2O methanol, H2O ethanol, carbon disulfide, non-polar, acetone polar. All of these examples will make up for positive deviation. If I look at the vapor pressure versus composition plot for negative deviation में क्या होता है? Total vapor pressure decrease कर जाता है. So this is the P total calculated using Raoult's law, and this is what we can obtain as the observation. So observed vapor pressure is less than the calculated vapor pressure. So remember this. There are certain examples that we can take. हमेशा याद रखिए, negative deviation will be shown by those systems which can react with each other. For example, chloroform and acetone can react with each other. They form a substance known as chloritone. So any two things which can react with each other will be capable of showing negative deviation. Chloroform acetone. Chloroform benzene, over here the pi electron cloud interacts with the hydrogen of chloroform. Chloroform and diethyl ether, they can react with each other. Acetic acid and pyridine, acid base reaction can take place. H2O HCl, H2O HCl, HCl can dissociate. HNO3 H2O, HNO3 can dissociate. Acetone plus aniline, they can react with each other to form imine. So जो भी दो चीजें हैं, अगर वो रिएक्ट कर सकती हैं, फॉर एग्जाम्पल एसिटिक एसिड को आपने पानी में डाल दिया, they can react because acetic acid can dissociate. So it will cause negative deviation. Any two things if can react, they will cause negative. Any two things which do not want to react, they hate each other, polar, non-polar, आपने मिला दिया, positive deviation होगा. Okay? So with this we finish non-ideal solutions part 1. In the next class we will discuss non-ideal solutions part 2, where we will talk about azeotropic mixture and we discuss the plots that we observe in azeotropic mixtures. Okay? It is not necessary to memorize the examples. You can understand it by evaluating the nature on your own. Okay? So please do like, share and subscribe our channel. Please don't forget to hit the bell button so that you can get all the important notifications in advance for any classes or any series that we are coming up with. And this is all I have to say. Please do join us for the next session. It will be on azeotropic mixture, a very important topic, a very misunderstood but easy topic. Okay? Chaliye, so with this I take leave and we'll meet up in the next class. Bye bye guys and have a lovely time ahead.